Well, in this section, we are going to consider case two of simultaneous equation. We have already considered case one of solving linear system of equations in two variables. We have already considered case one. At this time, we are going to consider case two. The case two is where two lines are parallel for given two equations. So I will try to write this on the board as you copy everything. Case two. Good. Consider two curves, L1 and L2. Sorry, consider two lines, L1 and L2. Consider two lines whose equations are of the form L1 is giving us a1x plus b1y plus c1 equals 0. And the second line is L2, whose equation is a2x plus b2y plus c2 equals 0. The two equations. When these two lines happens to have no intersection, let me write this one down. When these two given lines, L1 and L2, have no point or points of intersection whatsoever, as they may be parallel lines, then there will be no solution for the two equations when they are solved simultaneously. What's the meaning of that? Assuming you have two equations and you solve them simultaneously and there is no solution, then it indicates that the two lines are possibly parallel. They are parallel lines. Maybe parallel. Yeah. So we will illustrate this by taking some example. When this happens, is there any space over there? Okay, take your time to copy. to copy this one. Take your time to copy, and I'll come back again to continue the explanation. Take your time. Hence, we say that any two given lines L1 A1x plus B1 y plus C1 equals 0, and L2 A2x plus B2y plus C2 equals 0. If they are parallel, then they will have no solution. If they are parallel lines, then they will have no solution. Under such condition, or under such situation, where two given lines are parallel, we say that the two equations this is equation 1 and this is equation 2. We said that the two equations 1 and 2 are said to be inconsistent, meaning when you solve two given equations simultaneously and there is no solution, we say that the two given equations are inconsistent. They are inconsistent. Yeah, they are inconsistent or inconsistent, whichever. They are inconsistent. I would say the two given equations are inconsistent. As I said, we will take an example of everything that we are trying to explain. So in the meantime, you will take your time to copy everything, which whose portion is very valuable. I mean, to remember you of everything that we are talking about. So at this time, take your time to copy it, and then I'll wipe it off again, and we will solve question on this particular example, case 2, where two given equations are inconsistent, meaning they have no solution. Take your time, copy everything, and we'll come back again. Now, this is an example of case 2. Case 2 example. solve the simultaneous equations. L1 is giving us 2x minus 3y minus 1 equals 0. And the second line is giving us L2 is 4x minus 6y minus 1 equals 0. But there was something that I forgot to tell you. As I was writing this one on the board, I remembered. You see, before we came to this session, I said something about when two lines are parallel. You see, for instance, if you have, let's say, this is L1, and let's say this is L2. And the L1 was, is there any space over there? L1 was, this is L1 and this is L2. L2 was A2x plus B2y plus C2 equals 0. And the L1 is A1x plus B1y plus C1 equals 0. This was what I was trying to explain previously. And you can see that the two lines are parallel. And because they are parallel, they don't have any point of intersection whatsoever. And for that reason, when a case like this arises, we say that the two lines and the two equations are inconsistent. The two given equations are inconsistent when they do not intersect. In other words, they have no solution. That was an explanation I had wanted to give earlier. And I forgot. So you can also integrate this session on your notes, which is very, very important. Very good. Then I'll take the opportunity, based upon the same principle or based upon the same explanation, I'll choose the opportunity to let us solve this equation, and we will later on find out that it will be exactly like what we've explained here. Okay, let me take this place off. I hope if you didn't, this video script, you can pause it and try to copy everything that I wrote here. So this is one of the advantages of today's technology. This is said. If this should have happened in the mainstream education, it would be over. But since this is video tutorial, you can pause that session and copy everything. Now we come to the solution of this analysis. The first one, I'll call it equation 1, and I'll call this one equation 2. We can solve equation 1 and 2 simultaneously. Solving these two equations simultaneously, in fact, it's not a big deal. Write your solution. Very good. And then picking up from the equation 1, we have 2x minus 3y minus 1 equals 0. That's the first equation. And the second equation being 4x minus 6y minus 1 equals 0. Now, we can eliminate, if we try to eliminate x, if you watch this equation very carefully, if we want to eliminate, let's say for instance, x, then we can multiply the first equation by minus 2 on both sides in order to eliminate x. But there is something peculiar about this equation that, I just don't want to talk too much to confuse you, but you will see it very soon. You see, if I multiply the top one equation, the equation 1, on both sides by 2, I will possibly, and then we'll try to eliminate x. Look at what will happen. Multiply both sides by minus 2, then minus 2, then minus 2, then minus 2, and adding them together. You will say, wait a minute, what's going on? In fact, multiplying both sides by minus 2, it doesn't make the equation change, because you have multiplied both sides, because you have multiplied both sides, not one side. You have multiplied both sides by minus 2. By any reason, you can also divide both sides by minus 2 and you still have the same equation. This is a mathematical manipulation. This is it. So multiplying both sides by minus 2 doesn't make the equation 1 change at all, because you multiplied both sides by minus 2, and by any means you can also divide both sides by minus 2 and it will still remain the same. As I said, this is a mathematical manipulation, logic. Now, we can see that this equation 1 still remains the same as both sides are multiplied to minus 2. Now, let us try to add equation 1 and 2. Adding equation 1 and 2 will give, say, equation 1 plus equation 2 will give minus 4, the minus 2 times 2x, we have minus 4x. When we add it to plus 4x, which is this one, then we come here. Minus 2 times 3y is plus 6y, which is plus 6y. And then we add it to minus 6y. Now, we come to decision. Minus 1 multiplied to minus 2, we will have plus 2 and minus 1. We have wait a minute. Yeah, it's the same. And then we come to the right hand side. 0 being multiplied to negative 2 is 0. And then we add it to 0. We have 0 as well. So you can see that minus 4 plus 4x gives us 0. Plus 6y minus 6y gives us 0. And then we have 2 minus 1 equal 0. So that if we add equation 1 and 2 by solving it simultaneously, we can find that the resulting equation is 0 plus 0 plus 1 equals to 0. Where is x and where is y? We can see that by solving this simultaneous equation, by solving the two equations simultaneously, the x and y variables, they vanish. It tells you that, in fact, there is no solution. And where there is no solution, because we cannot find y, and neither can we find x, there is none of them in the resulting equation. For this reason, we say that it has no, the two equations have no solution. Therefore, the two equations are inconsistent. Therefore, the two lines, they are parallel lines. What's the meaning of that? We will see. Take your time to copy everything and I'll pick it up from there. But possibly, I think I have to, I owe you further explanation. You see, trying to solve the two equations simultaneously, it became futile. No results. We can't find any value of x here. Neither can we find any value of y here. Which indicates that, in fact, these two equations, if we solve them simultaneously, we will have no solution. And if we have no solution, then we say that the two equations are inconsistent. Then we can also say that the two lines are parallel lines because they have no solution, because they do not intersect to one another. That is the reason why we never found any the result of any x or y value. It tells you that the two lines, they have nothing in common in terms of intersection. Therefore, the only relationship that they have in common is that they are two lines that are parallel. They are inconsistent in terms of their equation. Take your time, copy it, and then we will carry it from there again. Take your time. Now, we are trying to push ourselves further for an extensive work. Let us pick the first equation. The first equation is 2x minus 3y minus 1 equals 0, which is not different from 2x minus 1 equals 3y, which is not different from y equal 2 over 3x minus 1 over 3, which is an equation of a line in the form ms plus c, excuse me, where the 1/3 is the c, which is the y-axis intercept, and m is the gradient of the curve, of the line. So this equation you can say that on the x-axis, y equals 0. We already know that on the y-axis, x equals to 0. When x equal to 0 in this equation, you can see that this portion will be 0. In that case, y will be minus 1/3. That says that the line crosses the y-axis at minus 1/3. What about on the what about where the line crosses on the x-axis? Where the line crosses on the x-axis, y should be put to 0 in either equation, in this equation or in that equation, whichever. So you can see, you can find out that this can be maybe more simpler. On the x-axis, y is equals to 0. In that case, we have 2x. When y is equals to 0, we have 3 times 0, then we have 0 minus 1, which implies is 2x equal 1, which implies is x equal half, which indicates that this line will cross the x-axis at where x equals to half, and it will cross the y-axis at where y equals to -3. It tells you that this specific equation will have a graph like this. By the way, you see that the gradient m is 2/3. 2/3 means it is positive 2/3. It indicates that the gradient is a positive gradient. So it crosses the x-axis at half. Let's assume here is half. X equal to half. This is y, and this is the origin. And then it crosses the y-axis at minus 1/3. Let's say someplace like here. This is just a rough sketch. So you can see that the line, this is the equation here. This is minus 1/3, minus 1/3, which is this one. Good. And this is the line 2x minus 3y minus 1 equals 0. This is that line. And also, you can say that you can use this equation as well, or y equal 2/3x minus 1/3 is the same line, the same equations. Very good. Then, secondly, let us go to the second line. The second line, whose equation is 4x minus 6y minus 1 equals 0. Let's see intercepts on x and y axis. Intercept on the y-axis, x will be equal to 0. In that case, this one is 0 then, because when x equal to 0, then 4 multiplied to 0 is equals to 0. Then this equation becomes minus 6 y minus 1, 0 equals 0, which indicates that 6y equal minus 1, which implies this y equal minus 1/6. Y equal minus 1/6, which is the y-axis intercept, which implies the line will cross the y-axis at minus 1/6. Now, intercept on the x-axis, y equal to 0 in this equation. So when y is equal to 0, then we have 4x minus 0 minus 1 equal 0, which implies is s equal 1 over 4. Now, what about the gradient? This is not a big deal at all. Is there any space down there? Let's see. Breaking down this equation from there, from here, we see that 4x minus 1 will be equal to 6y. Good. 6y. Let's see whether we can continue from here as well. Is there any space over there? I believe so. As I can see it on my screen, it indicates that you can see it as well. Therefore, y equal 4x over 6 minus 1 over 6. Y equal 2 over 3 x minus 1 6, which is of the form mx plus c. Now, you can see that the gradient here is equal to 2 over 3. M being the gradient is 2 over 3. Exactly equal to here. Here we can see that the m is equal to 2 over 3. The gradient of this line is 2 over 3. And this line as well, the gradient is 2 over 3. It tells you that in fact they are parallel lines. Parallel lines are parallel because they have, two lines are said to be parallel when they have equal gradients. This is it. So you can see that now it has proven that the two lines are parallel since their gradients are the same. Therefore, they can never, ever meet. This is it. Then you can see that on this same line, you can see that the y-axis intercept is minus 6. So if we are to sketch this graph, it will be something like this. You see the gradient is still positive gradient. Therefore, it will go this way. But at this time, we see that it is 1 6. So while the x-axis intercept was 1 over 4, so it is something like this. Here is minus 1 6, this one. And this one is x-axis intercept is 1 over 4. We will draw it properly, but this is just, take it easy. We'll have time to draw everything properly. So this is just a rough sketch. This is it. Now, what we are going to do is that we are going to, this equation, as I say, it is 4x minus 6y minus 1 equals 0. Now, we are going to sketch both equations on the same graph or on the same axis. Take your time, copy everything, and then we'll pick it up again from there. Take your time. Now, let's consider the two equations, plotting the two lines on the same graph using using this information that we derived earlier. The first one, we see that the x-axis intercept was, let's say it was half, let's say here, it was half O. And the y-axis intercept was 1/3, let's say here, minus 0 minus 1/3. So you can see that, or okay. And that equation was 2x minus 3y minus 1 equals 0. Or you can write this one as well. Or y equal 2 over 3x minus 1/3. They are both equation of a line. Very good. And the second equation was 1 over 4, which is here, good. And this is 1 over 6, which is something here. O minus 1 over 6. Can you see it clearly? I hope so. I hope so. Let me see whether you see it clearly. Oh, let me do it neatly. Possibly, I may have to wipe this one so we can do it neatly. Now, let's see. X. And let's call this one the origin. And let's say this one is O, half O. And this one is, let's say, one 0 minus 1/3. You can see that this line is something that goes like this. And that equation is 2x minus 3y minus 1 equals 0, or we can call it y equal y equal 2 over 3x minus 1/3. They are both the same. And then the second line is 1/4, which should be possibly half of it. 1/4. Can you see clearly? We don't have to risk, because 1/4 O. Good. Which is the x-axis intercept, and the y-axis intercept is minus 1 over 6, which is almost the half of the previous. O minus 1 over 6. So this line also looks like it goes this way. this was the L2, and this was the L1. In the L2, the equation was 4x minus 6y minus 1 equals 0, or we can say that is y equal 2 over 3 2 over 3x minus 1 6. You can see that the two lines, they are parallel and they have the same gradient, 2 over 3. That was the reason why it had no point of intersection. So these two equations, this is equation 2 rather. This equation, two equations 2 and 1, they are said to be inconsistent because they don't have any point of intersection whatsoever, and they are said to have no solution because they do not have any point of intersection whatsoever. Now, in concluding this part of this session, the case 2, we remember from the case 1 that case 1, two lines have solution if and only if they do intersect. Therefore, two lines will never have any solution if they do not intersect. They do not intersect, or they do not intersect, like this case. In this case, we say that the two equations, because they do not intersect, the two equations are inconsistent. That is the case 2. The case 1, where two lines intersect at a particular point, let's say line 1 and line 2, they intersect, we say that the two equations have unique solution because they do intersect at a point PXY in the plane. Now, I think this has been such a remarkable lesson at this time, and we celebrate it by giving thanks to the Lord Almighty God, that is to say, who gives us wisdom to deliver such a powerful knowledge to students, and to also, broaden the minds of the listeners, the students. And we say that to God, to the Lord Almighty God, be all the glory. Now, we'll bring this session until we continue the next session, bring the case 3. I will say that the Lord Almighty God bless you. The Lord Almighty God keep you. The Lord Almighty God make his face shine upon you and lift up his countenance upon you and give you peace. Shalom, shalom, shalom. God bless you. Bye. We'll see in this case 3 lesson. We'll see ourselves again in the case 3, lesson. Yeah.